All right, so we're in the back to the review problems. And again, I realize a long review. And I realize what some students might do is they say, well, I'll try some of the questions, but not all of them. And I realize that not everyone has all the time in the world to do things, but certainly I would say the more time you put into your studies, the better. All right. So I'm gonna pull problems to the side. I'll do one at a time. I'm kind of trying to do it in pieces. All right. So they want me to simplify this number 70. I'm looking at it. I do see double angle formulas, and I probably should know the double angle formulas. And let me just write them down for you. So the cosine of 2 theta, it can be written in a variety of ways. It could be written as a cosine squared theta minus sine squared theta. And yes, you should know these identities. It could be written as 2 cosine squared theta minus 1, or it could be written as 1 minus 2 sine squared theta. All right, 3 different ways. All right, so what I want to do is I want to look at this, and I want, which one of these 3 would I use on top to make my life easier? And I'm going to say, looking at it, I'm going to say on top I'd use this one over here, because I think it's going to make it easy for me. It's going to be 1 minus that thing. I'll write that down for you. So it's going to be 1 minus that thing. And I said that thing, I was going to use the thing in red. So it's 1 minus 2 sine squared theta. All right. Now I'm going to look at the bottom, and I'm going to use this one on the bottom because I believe it's going to make my life easier. Let me write that down for you. So it's 1 plus, again, that thing in green is 2 cosine squared. Now someone said it made it worse for me. If it does, erase it and try again. That's all I can tell you. Erase it and try again. I'm going to go over here, and let's see if we can write that down. Now, what would the top give me? The top would give me 1 minus 1 is none. Minus 1 minus 2 is just 2. So it gives me 2 sine squared theta. And what does the bottom give me? Well, I see the 1 minus 1 is none again, and I get 2 cosine squared. What's nice about this, the 2's cancel, and I recognize now the sine over cosine is going to be tangent, so it's going to be tangent squared. That worked out rather nicely. All right, that's number 70. That worked out nicely. It's simplified really nicely. Okay, let's go to number 71 now. Pull it on the side for you. I messed with it. My pen's a little bit jumpy today. All right. If the radius of a circle is 3 centimeters, then the measure of the angle that cuts an arc of length 6 centimeters is, well, I kind of remember this is beginning of the semester, that S equals R theta. It's kind of the defining feature of radian measure. Theta is in radian. And radian is a unitless measure of an angle. So what's S? Let's see, if the radius is 3 centimeters, I can write that down. All right, what's the arc? 6 centimeter. What am I going to do? Divide both sides by 3 centimeter. What do I get over there? Well, 6 divided by 3 is 2. Centimeters cancel. So what's theta? It's just simply 2. All right, that was our question. If you want to put degrees down, 2 times 180 degrees over pi. That's going to be approximately about 60 degrees, but they didn't ask for that. All right, but if the degree measure you want to put down, it would be 360 degrees divided by pi, which roughly speaking, about 120 degrees. All right, roughly speaking. All right, let's go to number 72. That's a simple question. I hope your exams, not too difficult. Let me, let's spill it over here. I'm sorry about that. Let me just push this out of the way. I guess I'm on 72 now, right? Push this out of the way. Okay. A truck is moving at 60 miles per hour. And I'm going to say at velocity. Okay. The diameter of the wheel is 24. Well, We like circles, so I'm going to put radius down. The radius is 12 inches. Well, it's a small wheel, isn't it? Find the angular speed. Wow, they want omega. That's the angular speed. Let's write this down. S equals R theta. I'm going to divide through by T. S over T we call V. R, and omega over T, I'm sorry, theta over T we call omega. All right. I have troubles here. I want to be honest with you. They want radians per minute. So I got some trouble. I'll put them down. So I don't want hours, I want minutes. And the other thing is I got miles and I got inches. So I have to make a conversion here. I'm going to write this down for you. By the way, these things are in the footnotes, and you may want to look at that if you don't know this. I would say if you did not grow in the United States, this is kind of like, knowledge that you really probably don't know. But if the United States, we probably should know this, especially if you're going into any kind of career that involves, the STEM fields. So let's take a look. Let's do hours to minutes first, though. So I'm going to say there's, in every 1 hour, there's 60 minutes. And that's what's known as a unit conversion factor. What cancels over there? The hours would cancel off, and that's good news. Geez, what else cancels off? The 60 cancels off, and that's good news. All right. So if I were to write this one down, just, V, this would be 1 mile every minute. Well, I kind of knew that. But now I want to get rid of miles and go to feet. So I'm going to say there's 5,280 feet. I'm sorry, I didn't put the 0 down there. And I don't think this is general knowledge to most people in the world. The United States, it probably is considered general knowledge. But again, I could forget it too. It's not that important to me. 5,280 feet in every 1 mile. Well, what cancels over there? Miles cancel now. But I still got to get the inches. So then the question becomes is how many inches are in every foot? I'm going to say 12 inches in every 1 foot. And that's a unit conversion factor. What disappears there? Feet. So I got V now. I'll write V down for you. V is 5,280 times 12 inches per minute. All right. Now somebody says there's so much work, I'll never be able to get to the end of the problem. Well, I got to start writing things down now. And I'll write this up. What's V? Well, V is 5,280 times 12 inches over minutes. I'm using this equation here. And what's R? That's 12 inches, right? And then times omega. I think I could solve that. Divide both sides by 12 and divide both sides by inches. And you get something really simple. What do you get? 5,280 per minute. That's the omega. All right, let's go back to the question. And what's the question? Radians per minute. I have the answer, 5,280. All right, not bad. All right, glad I didn't do the multiplication. 12 times 5,280. All right, let's take a look at the next one. And I guess I just did number 72. By the way, some people, why do you choose those numbers? I choose those numbers in the word problems because they're kind of simple. All right, I'm going to look at number 73 now. All right. Okay. I know this is very confusing to students, but I want to point out when you're confused, draw a picture. All right. And the wheel's going to bust goes around. I know n is some angle between 0 and 2 pi, So I'm just going to put this over here. I don't know what n is, but I know n is some angle. I know it. I know n is an angle. How do I know that? I'm reading it. And then they said, it's really equal to the number x. Letter x, by the way. All right. All right. So you could just say n or x. Doesn't really much matter. Then they go on to say sine of x is equal to m. By the way, that's the same thing as saying sine of n is equal to m. Right? So I kind of understood what they said in that first sentence. But then they go on to say, find another solution to the equation. And what I'm going to claim over here, it would be nice if you can remember back to the beginning of the semester. And what I said about this over here is that, well, the references would be n. It's got to be an n reference angle. So this really is my reference. Right? Now, I'm going to say that looking at it, I would know that m is a positive number because the sine of an angle in that first quadrant would be positive. Where else would the sine be positive? In the second quadrant. So I'm going to put it over here. There'd be an angle over here. And what's the angle over here? The reference is still, all right, this over here, is still n. So what's the angle then? What's the angle? It would be pi minus n. All right. So another solution to the problem would be pi minus n. And again, this angle over here is pi minus n. Or if you prefer degrees, you could write down 180 degrees minus n. But n would have to be in the in degree measure in that case. All right. Now I'm going to erase that because I really think we should answer it in radian. All right. So let's look at K, see if we got the right answer. Yep, I knew about references, and that's a good deal. All right, let me go back. That was 73. I'm going to go to 74 now. By the way, everyone gets stuck. I get stuck sometimes too. And if you're on the exam and you're getting stuck, what I'm going to say is leave the question and come back to it later. Now, if you're in a panic mode, if you get stuck on the first question, you could be in an infinite loop saying, I can't move forward. Move forward, all right? Well, I'll write down what they've given me. They've said the sine, well, let me get the black ink. They said the sine of x plus the cosine of x is equal to 1/2. But their question is, what's the value of sine x times cosine x? Now, granted, I'm not saying that you're going to do it the way I do it, but certainly I'm looking at this and I'm wondering, how could I do that? It looks really tough to me. I got to be honest with you though, there's no way they're going to give me a question that's really tough. It's always got to be easy. So I'm going to play around with it. The first thing I would like to do is just try this. I want to square both sides and see what happens. And what would you get over there? Sine squared x plus 2 sine x cosine x plus cosine squared x equals 1/4. Again, that could be a dead end. Maybe it doesn't go anywhere, but I'm starting to think maybe it does go somewhere. And what am I noticing over here? I want to point this out to you. I'm seeing a Pythagorean identity now. And what is that? The number 1. So write that down for you. 1 plus 2 sine x cosine x. And what does that equal? 1/4. Now what I'm going to do, I'm going to subtract 1 from both sides. And what do you get? 2 sine x cosine x equals minus 3/4. Again, you need to know basic arithmetic. What's their question? What's sine x cosine x? I think I see it now. Sine x cosine x, divide both sides by 2, minus 3/8. Let's look at our answer, K, make sure it's there. And I'm seeing it. All right, so let me point out what we've done. We've done that page. I'm going to the next page now. And we'll do 75. By the way, there's many ways to do the question. I'm not saying there's only one way to do it, but certainly I'm looking at it. I want to try. And what I'm going to do is this. Cosine, let's go back to black ink. Sorry about that. Cosine of 2 theta would have to equal minus 1/2. All right. All right, I'm going to try to solve for 2 theta. How do I do that? I'm going to draw one cycle of the cosine curve. It looks like this. And where's minus 1/2? There and there. Now, so again, I know my pictures aren't great. I know the first one occurs between 90 and 180, and the next one occurs between 180 and 270. My goal is to get the reference angle, though. All right, reference angle, acute angle. And what function gives you 1/2? Let's see. That'd be 60 degrees, right? All right, that's a reference. Now let me write this down then. I'm solving for this over here. So 2 theta is equal, well, let's see, it's between 90 and 180, right? What angle between 90 and 180 is a reference of 60? I say 120 degrees, right? Plus 2 pi k, with the understanding that k is some integer number. I'm not saying that's the answer yet. Let's do the next one. The next one's between 180 and 270, right? Reference is 60. And what would that be? Let's see, between 180 and 270. So I'm at 180, goes 60 more, 240. And again, k is some integer. All right, I got to write the answers down now. What's going to be theta? I'm dividing by 2. 60 degrees plus pi k. I divided this equation by 2. Now I'm going to divide this equation by 2, and you get theta equals 120 degrees. I'm sorry, I'm mixing, and I really apologize. I could get my eraser out, and this is crazy. I mixed. It's like mixing language. I just noticed it. Whoops, I didn't erase it fully either. Cycle length is 360. Go black. What's that going to be? 2 and 360 is 180 degree K. Okay, we typically, by the way, I don't mind the answer, but I want to write the radian down. And what's that going to be? 60 is going to be pi over 3, right? And what's 180 pi? Let's do the other one. Well, this is 2 times 60, which is 2 pi over 3 plus pi k. Again, I want to point out the understanding is k is any integer in the universe, right? 0, 1, 2, minus 1, minus 2, yada, yada, yada. Let's look at the answer to see if we got it right. Gee, great news. All right, let's go to 76. And 76, again, you might say, I have no recollection. And that means you go back and study. All right. A lot of times I have no recollection either. I have to study. And what's the problem with studying? It takes time. All right. So let me remind you, I see Z. I want to get back to black ink. Z is minus 1 minus I. And again, I want to remind you, our goal here was to write it in the polar form or trigonometric form, where this was the real number, this is the imaginary number. And what is it going to be? Minus 1 minus 1. And where would that be? Minus 1 over here. So I'm going to say that's a fairly easy angle. It's fairly easy. So what do I need? The argument. This is the argument. For that would be, the reference is 45 degrees. So it's, 180 plus 45, 225 degrees. And the R for this thing over here, it's fairly simple. X squared plus Y squared. That's 1 plus 1, which is 2. Root 2. That's pretty simple. which is going to be r, which is root 2. That's still the modulus. And then it's going to be cosine of 225 degrees plus I sine 225 degrees. Now, what's their question, though? Find the trigonometric form of z. I just did that. It's right here. Well, I think I did that. Yeah, they just expanded it. Doesn't make it any different. Now they want Z9. What does that mean? -1 minus I to the 9th power. And by the way, you know the binomial theorem, you could expand it. It'd be a nightmare, though. I want to use that theorem I know about. And let's write that down. Root 2 to the 9th power times cosine, this is going to be a tough one, 9 times 225 degrees plus, oh boy, I got to move over here, I sine 9 times 225 degrees. Yeah, I hate to say it, I do have some work on my hand, all right? And what I want to do is, I want to do root 2 to the 9th first. I want to see if I can do it. I don't know if I can do it. Well, I'm going to say root 2 to the 8th times root 2. And that would be 2 to the 4th times root 2. 2 to the 4th is 2 times 2 is 4, 8, 16 root 2. Let's write that down. Oh boy, I got troubles now, don't I? 9 times 225 degrees. Let's see, 45, 22. Whoa, that's a big number. Cosine 2025 degrees plus I sine 2025 degrees. I know it's a lot of counting. I got to get my eraser out, though. It was just this grade school arithmetic on the side is kind of annoying. And by the way, I'm not at the stage where I'm checking my answers. I'm going to start writing the multiples of 360 down for you, though. Right? Let's see. Another 360, you get 1080, right? I could keep adding on here. Well, I'm going to add 720 to that now. That's twice more around. And what's that going to give me? Let's see, 1800, right? Oh boy. I'm getting close though, aren't I? And I don't want to keep going. So I'm going to say, I'd eventually get to 1800. And these are multiples of 360, right? This is one of them, 2 of them, 3 of them, and this would be 5 of them. All right, let me put out what I mean by that. 1, 2, 3, 4, 5. I'm getting hypnotized. How much more do I have to go? 225 degrees more. Let me get my eraser out. I think I can do it. I think I can go 225 degrees more. I'll put this over here for you. Again, for the students faster at this, good for you. If you're slow at this, practice. So what's 225 degrees? 90, 180. Whoa, 45-degree reference angle. I think I'm ready. 16 root 2. What's the cosine of that? -1 over root 2. What's the sine of that? -1 over root 2. I need to multiply that out, by the way. And what would you get? -16 and -16i. Okay. Oh, they want me to find z in standard form too. That's standard form, by the way. And I did put the trigonometric form down. So I got it all done. Everything is done. I have this one down as well. All right, right over here with the 225, the 2025 in it. All right, let's see what we got. We got 76. Let's go to 77. And again, I know it's tedious, and for some people it's incredibly boring. And that's one thing I want to point out in your educations. You're going to find things that you're incredibly bored with. And you really need to, you're adults now, you really need to focus on, not what you're bored with, but what you're excited by. All right. So let me see if I can do that. All right, let's write this down. And I'm going to remember what I've done in the past. I like talking in degrees, though, I'll be honest with you. So I'm going to say, 0 degrees. And I'll translate back later, 360 degrees. Now I want to do the solution to the problem and what I've done in the past. And you may not remember this, and it's really going back to, I guess this is not week 3, but lecture 3. I draw one cycle of the tangent curve down. Then I put the ratio 1/√3 down. Hits it once between 0 and 90. And then I wonder what the reference is. And the reference for 1/√3 would be a 30 degrees. I'll write this over here. So theta reference is 30 degrees. Well, again, it's in the first quadrant. So the angle, x, is 30 degrees plus the cycle length of the tangent function, which is 180 degrees. Again, the understanding that k is an integer value. All right. Now they want me to stick between 0 and 360. So I'm going to write these down now. So if I took k to be 0, I would get 30 degrees. If I took k to be 1, I would get 210 degrees. Now, if I took k to be 2, I'm beyond 360. So I have my angles in degrees, but they don't want me in degrees. They want it in radians. It's written up here. Let's write this down. So what's 30 degrees in radian? I'll write this over here for you. Pi over 180 degrees. It's just going to be pi over 6. Now, I want to point out that 210 is really 7 times that. So I get 2 answers, pi over 6 and 7 pi over 6. These answers are listed for you. All right, let's keep going. And we're going to go 78 now. All right. Okay. Again, they're giving me an interval. I see it, and I got troubles. All right, so let's just talk about it. And what I'm going to do is just go back to what I've done in the past. And I'll worry about their question later. And for the most part, I'm going to be talking in degree mode. So I'm going to try to stick between minus 180 degrees and 180 degrees. All right. Okay. So I got to figure out, and the way I've been doing this in the classroom is I've been not graphing cosecant. I've been graphing a related function, which is the sine function. So I'm going to write that down. Sine of 2x plus pi over 2. And let me put the begin and end down for this. All right. Put this down for you. So the begin is when the argument equals 0. And let me do the end. And what's the end of this thing over here? Well, it's when 2x plus pi over 2 is equal to 2 pi. Well, this is 2x equals minus pi over 2, or this is where x is equal to minus pi over 4. All right, that's minus 45 degrees, by the way. Let's do this one a little more complicated. 2x equals 4 pi over 2 minus pi over 2. So 2x would equal 3 pi over 2. Right, I hope I didn't go too fast with that, didn't I? 2 pi is same thing as 4 pi over 2. Subtract pi over 2 from both sides to get 3 pi over 2. And what's x? Well, it's going to be 3 pi over 4, right? I know it's tough, but I think you know what I'm going to do now. And again, you might say it's going on too long. I need to be quicker at this. That's where practice comes in. All right, take a look. I want the center of that. Add them together. You get 2 pi over 4, right? Divide by 2, get pi over 4. Now I want to get the center of these two, add them together and divide by 2. Well, that couldn't be any easier, just 0. I want to get this guy's center, add them together and divide by 2. Well, that would give me 4 pi over 4, so it'll be 2 pi over 4. Oh, sorry. All right, so what goes over here? It's really y, and what's y? Well, if you can't remember, just make sure you go back and reread the problem. I think I know what it is. It's going to be sine 2x plus pi over 2. Let's go to town, plug it in. All right, so if you plug in minus pi over 4, you get minus pi over 2 plus pi over 2 is sine of 0. And the sine of 0 just couldn't be any easier. It's 0. Let's do the next one. If you plug in 0 to get sine of pi over 2, well, lo and behold, that's also easy. That's just 1. What's the next one going to be? We'll put pi over 4, pi over 2 plus pi over 2 would be pi, and the sine of pi is 0. That couldn't be easier. Let's keep going. I got another one to do. Sine 2 pi over 4, which is pi over 2, times 2 is 2 pi, 3 pi over 2. Which is minus 1. Last but not least, you multiply that by 2, you get 3 pi over 2 plus pi over 2. It's going to be sine of 2 pi. I think I'm ready. Let's see. Minus pi over 4 is 0. That's that point there. Right? 0, 1. It's up there. Pi over 4 is 0, it's there. 2 pi over 4 minus 1, right about there. And 3 pi over 4, 0. And this is the sine function, right? And the problem is, you could do this all day long. And, I don't want to do it all day long, but I certainly want to know what we're really graphing out. We're graphing out the secant function. It's reciprocal, isn't it? And I want to put asymptotes in here. I know it's tough. Let's write them down. What's this one over here? Well, it corresponds to this value here. And what was that value? Minus pi over 4. What's this value? Well, it corresponds to this one, which is pi over 4. And what's this value over here? Well, it corresponds to this one, which is 3 pi over 4. So again, you may not remember this, but I want to point out what we're looking at over here. These asymptotes are spaced beautifully. And what's the space between them? Well, if you look at these things over here, the space between them is actually pi over 2. Space between these is pi over 2. So I'm going to say they're the general form, these asymptotes. I'll write this down for you. They're of the general form, x equals minus pi over 4 plus some multiple. And again, if I'm looking at, I want to point out I'm looking at the distance between those things is going to be, 2 pi over 4, which is pi over 2. But I'm going to write it as 2 pi over 4. For example, if k is 0, I'd get this one. If k were 1, I would get this one. If k were 2, I would get this one. I want to go back to their question, though. And what do they want to know? Let's go back to it. They want to know these between minus pi and pi. So they want these that are between minus pi and pi. Well, I'm going to write them in terms of pi over 4. So that'll be minus 4 pi over 4 and 4 pi over 4. Well, I'm going to start writing them down. I'm going to write x0 down first. And that's where k is equal to 0. What would you get? Minus pi over 4. I'm going to write x1 down. And what would you get over there? Well, looking at it, you would get 2 minus 1, which is pi over 4. All right, I'm going to put x2 down. What would x2 give me? That would give me 4 minus 1, which is 3, pi over 4. I hope you realize that if I keep going, let's go to the next one, x3. What would that be? 6, it would be 5 pi. I hope you realize we're way out of bounds. Let's go backwards. And what would you get there? You'd get minus 3 pi over 4. That's in bounds. And what's x minus 2? That would be minus 5 pi over 4. And I hope you realize we're out of bounds over here. So I think I found them. A lot of work. And I want to go back to the answer key. And I know it's tough. I'm saying I can't do it. I'm gonna take that answer key. Pull it over here. I'm gonna blow this thing up. See how we did. And I'm the first one to note if I make an error. I really mean that. Bingo. We did good there. Again, I hope it's not too difficult for you, but we did good. All right. And again, I know you guys are, especially if you're not putting a lot of time and effort in, that this must be really difficult for you. And you're not alone. All right. You're not alone. Let's go to the next page. Give me 1 second. And I'll look at this one over here. Oh, this is nice. This is a gift. A compliment. All right. A compliment. And what's that going to be? That's going to be pi over 2 minus pi over 6. Common denominator would be 6. That would give me 3 pi minus pi, which would give me 2 pi over 6, which is pi over 3. Okay, next one. Oh, fifth degree related to a fifth degree polynomial, right? Let me pull this inside. Look at that big job. All right, looking at it, and I want to use zero product rule. So see if I can do that. And it really does look tough. I'm hoping it's not going to be tough. I want to point out it can't be tough. I'm going to use the zero product rule if I can factor. Let me remind you, we did Math 100. You did factor by grouping. Let me see if I can do it. Now, I'm hoping your teachers in Math 100 told you to use the sign in the middle. I'll do that. And that would be 1, right? And what would that give you? Use square bracket there. Isn't that convenient? Okay, let's talk about each one separately. And I want to concentrate on this one right over here. For this to be true, the sine squared x would have to be equal to 3, which means the sine of x would be plus or minus the root of 3. Okay, I want to draw the picture for you. And again, this is what we've done in the past. The sine function looks like this. Now, then I draw the ratios down. The ratios are root 3, and root 3 is bigger than 1. Minus root 3 is much less than 1. This has no real solutions, though, so no real. I don't have to worry about that. Let's do the next one. I'm going to do this now. For this to be true, sine cubed of x would have to equal 1. Well, again, we're in the real number system. What number, when cubed would give you 1, that means the sine of x has to equal 1. Well, we've already got a picture, so let me draw it in. It only happens once. And what does it happen? It happens when x is equal to pi over 2. But it keeps repeating itself every 2 pi k. Well, you know what? I don't remember their questions. I'll go back and read their question. And their question is, they just want the answers between 0 and 2 pi. Well, I only got one answer between 0 and 2 pi, pi over 2. All right, so x is pi over 2. All right, fairly simple question, by the way. That's number 80. Let's go to 81. And oh boy, this looks like a tough one. All right, let me draw a picture of this. I've got the ground. I've got a pedestal. All right. The Statue of Liberty is 46 meters tall. Right, we'll put the statue down. It's a woman, right? I guess she looks sort of like this. All right. Not a very good Statue of Liberty, but the Statue of Liberty is 46 meters tall. That's a really big meter. She's 46 meters. All right. And hey, sometimes you can misread too. I'm not saying you can't. The Statue of Liberty is 46 meters tall, but she stands on a pedestal that's 47 meters. Okay. An observer is located d units from the center. So I'm going to say this is the center. And that guy is way over here, and this is going to be d. All right, this distance here is d. And he's d meters. Okay, find an expression that represents the angle theta in terms of d. Well, let's take a look at what he's doing. The observer is located d meters from the center of the pedestal and is leveled at base. Find the expression that represents the angle theta in terms of d. It's a little complicated here. And I wonder what the theta is at this one. I got to read it again. The Statue of Liberty is 46 meters tall and stands centered on the pedestal that's 47 meters above the ground. An observer is located d meters from the center of the pedestal and is level with the base. Find an expression that represents the angle theta in terms of d. You know what? I don't know what theta is in the problem, and there could be a variety of things. And I think maybe this thing deserves a picture over here, but I'm going to put this over here. My suspicion is this, that they're talking about this theta. Okay? We're talking about that. So let's see if we can do it. All right, let me look at it. And let me draw my triangle in for you. And again, I'm going to say there's got to be a theta somewhere in the problem. I'm not sure what theta they're talking about, though, but we'll look at their answer. And really, there should be a picture associated with this. So let's take a look. All right. So I'm going to write down tangent of this angle here. I'm going to call this big angle here A. All right, let's write that down. What's tan of A? Well, it's this side over here What's 46 and 47? That's going to be 80, 93, right? And that's in meters over D. All right. So what's the angle A equal to? Arc tan of 93 over D. All right. That's that big angle A. Now I want to do this angle over here. I'm going to call it B. Let's write this down now. So the tangent of B is equal to the opposite, which is 47 meters over D. So what's B equal to? And there's many angles we could put down, by the way. So B is going to be equal to the arctan Ah, 47 over D. What's this angle? Well, theta is going to be equal to A minus B. Let's write that down. What's A? Arctan. And this problem really deserved a picture, by the way. 93 divided by D minus the B, which is arctan, 47 over D. That's clearly written over here. Again, this question here is missing a picture, which would be a terrible thing to do on the exam, but that generally doesn't happen. All right, the picture is what we're giving you over here. This is the picture. And certainly that we got the right answer. All right, that was number 81. Let's go to 82. And 82 is a question. Let's pull on the side. Put that over there. This is easy, right? Really easy. They want to write the first 5 terms starting with A1. That's the formula. It's going to be 1 times 2 to the first power, which is 2. That's done. Let's put down A2. What's that going to be? 2 times 2 squared. What's that going to be? 8. That's done. Let's put A3 down. That's going to be 3 times 2 cubed. Well, it's going to be 8 times 3, which is 24. That one's already done. 24, 24. Let's put down A4. That's going to be 4 times 2 to the 4th power. They're getting more difficult. 2 to the 4, 2 times 2 is 4, 8, 16. 16 times 4 is 64. All right, let's put down A5. What's that going to be? N. What's N? N is 5. And 2 to the 5th power. That's 2 times 32. That's 150, 160. All right? The question is it arithmetic or geometric or possibly neither? Well, right now, I'm not saying arithmetic because, 2 to 8, there's no common difference between those two. Like the first 2 terms, the difference is going to be what? 6. And then the next guy's, the difference between those is 16. And the next guy difference is 40. So it's definitely not arithmetic. Is it geometric, though? Well, let's look at the common ratio. To go up here, be a multiple of 4. Unfortunately, that fails. So it's not arithmetic. And it's not geometric. So what's our response? It's neither. All right. And I'm going to just, let me see if I go to the next page over here and see what there is there. You know what? I'm just going to take a break. And when we come back, we'll do 83 forward. All right. I think we can handle it. All right. Thank you.